Good morning, everybody. Well, so many people are really want to know how to fail with SD-WAN today, right? Okay, jokes aside, let's start with our sessions. Thank you for joining me today. We have a session, quite an interesting one, I hope, for you. So its name is 7 Ways How to Fail with Cisco SD-WAN. And the idea for the session really comes from 2 different places because, one, I seen a similar session from my colleague, which were running very similar name of the session, but for the wireless. But the way I see it is a little bit different because that's the second part of the story. What I normally see along my day job in tech and Cisco tech, I constantly see around Cisco SD-WAN that people are starting and pushing and stretching the solution to the very limit. And they're doing a lot of assumptions. They're actually pushing embedded built-in guardrails and safety belts which are really out there all the time. And that leads sometimes to a meltdown, sometimes some kind of a disaster with their networks. And we have 7 specifically use cases from our experiences I wanted to share with you just to let you know how you can really make a pain to your network, to your SD-WAN network, and obviously how to prevent that, what leads to that, and what you can do to really understand where you are on that journey. So let me briefly introduce myself. My name is Denis Konintsev. I'm a technical leader of Cisco SD-WAN team based in Poland, Krakow. I'm in industry since 2000, early 2000 years, and with Cisco I'm since 2007. I was doing very different roles along my journey. I was really engaged with multiple different technologies in service provider market, including broadband, mobile networking, and recent years, and specifically last 8 years, are really engaged with SD-WAN solution. I was designing networks, now I'm troubleshooting networks, so hopefully I will share my experiences and that will be helpful for you. So let's get started. So first of all, I basically already make you understand what we are going to talk about. We will have 7 cases, and the workflow for each case will be the same. So we will take a look, what was the intent of the customer? Okay, and obviously I will know no way we'll be sharing the names of the customers because we are not supposed to do that. But the entire context will be the same, so you can really kind of reflect that on yourself if your network can really be in danger for the same reason or not. And for average case, the workflow, as I said, will be the same. We'll take a look on the intent, what they actually did, and how it results in something which was not expected or not desired, and how you can really confirm if you hit on the same challenge or same limitation or same restriction, and how you can prevent in your network in the real life. So that's the workflow for each case. I will start with a very simple one, and I would say it's a little bit artificial because it's not like it's created from nowhere. We've seen that a lot, but in the past. Nowadays, it's less common, but still, just to warm up the whole conversation, I will start with a very basic one and very simple one. So let's get started. So I would start with 2 wordings. The first one really, I think everybody knows that. That's basically a different version of Murphy's Law. If something bad could happen, that would happen. Anyway, the question is when. So, and you really want to be prepared. And another one is kind of very fine line across the entire presentation, that most of those cases are really coming from bad assumptions and lack of, sometimes, and again, we are doing assumptions because of lack of knowledge, or because we were unable to find the source of the truth for the question we have. So these are blind spots and the gaps I'll be willing to cover today. So let's start with some basic stuff. And first of all, I'd like to share with you some acronyms. You don't really need to remember those acronyms. We will be using that across the entire presentation. That, just for your reference, you will get your presentation afterwards, so you can just take a look which acronyms we're using whenever you feeling you don't really understand what are those words or names out there. So let's start with the very first case. I call it breaking obvious rules. And let me kind of give you a refresher. That slide you've seen a lot of times. And again, I really missed one important part. This is indeed an advanced session for SD-WAN. So there is a specific expectation for all of you that you know what SD-WAN is, how it generally operates, and you don't really come here to learn about basics of SD-WAN. If you come here for that, unfortunately, you enter in the wrong door. So probably, I just want to kind of set your expectation properly. Going back to our case. So that slide you've seen multiple times since the early days from Viptela to nowadays. It basically shows you how we automatically builds up our control plane and data plane tunnels without doing nothing. We're virtually doing nothing. We just run a device which connects to the network. It reaches out to our controllers, learn about other vManage and vSmart, establish control plane connections, learn about the tunnel endpoints of the other devices, and establish IPsec tunnels and BFD sessions on top of it. So this is something happening automatically, or automagically, if you like. And we are really used to it. We are not thinking if it could bring us into trouble. And it really could, as you will see. And again, moving forward to specific case. I'm placing myself in the shoes of a customer. And customer was really having, let's say, 100 or 200 devices. Some of those devices, most of those devices, are very low-end devices like ISR 1K. And this is totally makes sense if you are trying to connect your remote location to the center DC or hub, which is normal practice, I would say, nowadays. And there was no specific requirements for that network. We just need a connectivity. We just need to run it. So we just need to send some basic templates, configurations just to establish connectivity across all the sites. So again, nothing fancy, just basic templates, and sometimes no policy at all. And that's important part. So what do you get in the end? For quite some time, everything worked just fine, no issues. You see all the traffic works and forwarded across your expectations, along with your expectations across your network, and nothing really telling you that storm is coming to you. Then something strange is starting to happen. And again, network is actually evolving over time. You add in some new devices, you moving devices from one location to another, but you're not really doing any changes with your configuration or your policies. But then you're starting to see that some of BFD sessions, which are essential for forwarding, because unless we have up and running BFD session, we are unable to forward traffic into specific IPsec tunnel. These sessions randomly starting to fail without any visible reason. You've checked with the ISP, you've checked with your devices are not failing anyway. You don't really see any major issues or any errors which might be indicating of some kind of software failure or software defect. So I'll give you just 1 second just to think about it. What could be the cause in that? And I will switch over to the next slide, and we will discuss exactly the root cause of that issue based on those inputs. Again, I'm not expecting you to kind of raise your hands and answer that question, but rather think it out loud and think it in your head and just pretend you are in that situation, what would be the cause? Okay, so the actual cause was scale limit. And you can easily say that from the title itself. Because we were using low-end devices, and those low-end devices has a hard limit of number of tunnels that could be established at the same time. At this specific point, whenever you are not using any policies which will be limiting the number of establishing the tunnels you are trying to establish from each device, each device will be trying to establish a full mesh to any other devices. Again, this is a very basic, very first one, just to warm up. And nowadays, I need to admit that it's not very common, but initial days of Iptela and SD-WAN and Cisco, that was something, to be honest. And the most important part, what you would expect, okay, I have a hard limit inside my box, which should not allow to establish more than 200 tunnels per one device. But my expectation that, okay, I've reached that limit, and I will just no longer I will not be able to establish new tunnels. But that's not the case. This is not how it works. The way it works in reality, whenever a device reaches its limit, it still will be trying to establish new tunnels, affecting previously established tunnels. So previously established tunnels, which were running perfectly fine, might be seeing issues because of that. And that's something you're probably not expecting. So there's no so-called co-admission control from that perspective. And that could happen once you just add, let's say, 201 device ISR1K, for instance. Before that, everything was just fine because you were running 200 tunnels from each device. So how can you really prevent that, and why you seeing that issue? The reason is default behavior. You are using default behavior when each device tries to establish full mesh of tunnels. So how can you prevent that? And first of all, how can you confirm that? Because that's very important. You might be mixing the same symptoms with a different issue. So let's take some outputs to really check that. And the very first one is really checking the BFD sessions. Why we are checking BFD? Because that's the part of the solution which will tell you the most efficient way and the most rapid way when something goes wrong with the data plane. It's not IPsec itself. We are running BFD on top of IPsec. So I really recommend to check BFD first. And what to look for? You can run commands like show SD-WAN BFD summary, and you can instantly see the number of sessions, which are up, which are total, etc. But the numbers you really need to look for is the number of flaps, and the total of sessions expected, and the actual number of sessions established. If you see a discrepancy there, that's a clear indication of a problem. It's not an indication of that specific problem we are talking about with the scale limit, but that's definitely you want to double check. What you can do next, and you want to double check if control plane is really contributing into the issue. You want to rule out that part, just to understand. And why is that? Because data plane depends on the control plane. If something happens on the control plane, it will be propagated into the data plane. So you want to rule out the control plane as a next step. Finally, I would recommend to check the OMP statistics as well, to really see if the number of TLOC updates, TLOC routes, is increasing rapidly, because that would be an indication of abnormal behavior, unexpected behavior. You are not supposed to see, you're actually supposed to see a slowly increased counter, but not fast increased. Again, I cannot really define that words slow and fast, but you can really compare the normal operations, and you can take a look on your environment and how it works, and then compare with some situations you will see in the future. Hopefully not, but If you see that, you will know what to do. So the next step would be to really understand if we are not seeing local issues with that device. And again, this is perspective for specific device. We would like to see if interfaces we are connecting that device to the rest of the network is not flapping. Because maybe it's not an issue with BFD, and maybe it's not the tunnels were affecting us, but rather some kind of local issues with ISPs. It's very less likely to have issues with both ISPs if you have two different circuits, but still this is something you really want to rule out, because you can have the same symptoms for very different problems. And that's the point I would say when I highly recommend to double check the scaling. If you come to that point and you don't really see anything else, you just need to go to data sheet or configuration guide whenever you can get that scaling for your device. Or probably you just can instantly figure it out. Okay, maybe I'm hitting the scale right away, and you just checking that. But also you can really run some sophisticated btrace commands, which are essentially a debug, extensive debug for the process responsible establishing BFD session. And that process is called FTM, Forwarding Table Manager. So you can run a so-called btrace for FTM process. And if you hit that issue, you will see a specific message which will tell you, OK, I have risen out of resources. That's another option to confirm if you're hitting the issue. So how can we prevent that? So this is why we are here, right? We want to understand how we can avoid that. And the answer is pretty easy, to be honest. So if that's a hub and spoke topology, but you are not really implementing any policies, you just have a full mesh, maybe that's the time to consider moving to the hub and spoke. By implementing centralized control policy, you will be limiting the number of tunnels initiated from lower-end devices. Normally, customers are using a couple of tunnels to the hub device, or 4 tunnels to 2 hub devices. This is the most common practice. And that would solve pretty much all the issues from that perspective. Other option is, OK, you can really think, okay, I really need full mesh sometimes, because without full mesh, you need to go through the hub device if you need to forward traffic from one spoke to another spoke. And sometimes it's not desirable. So what are the other options? The second option is to really enable not just hub and spoke topology, but also so-called on-demand tunnels. This is an alternative to DMVPN, when we had an option when you need a direct tunnel between the spokes, you can create it and establish it on demand whenever there is a traffic between those spokes. This is also supported by SD-WAN, I guess you know that. And there are a few other more sophisticated options how you can deal with that. You can use multi-region fabric, or previously called hierarchical SD-WAN, which will give you an option to really kind of build hierarchy with your SD-WAN network. And if all of these options are not matching your expectations and you still need a full mesh, unfortunately, you need a bigger device with a bigger scale. That's the only option. Anyway, moving forward to the next one. I've named it breaking not so obvious rule comparing to the previous one. And again, we are making some assumptions here again, and how we can fail with those assumptions. That's a tricky one, because to be honest, I've never thought someone will try that in production. But people are really creative whenever they need to kind of reach out their goals. And the customer tried hard to overcome the limitation of I would say ISP connectivity they have. So let me kind of briefly explain that. The most part of the network is connected to just to MPLS network. So basically, all the edges connected to the MPLS, all the controllers are connected to MPLS only. So there's no internet connection for the most part of the customer SD-WAN network. But then there is kind of sitting aside one single device which is not connected to that MPLS. And for very good reasons, because there's no point of presence for that ISP. But there is internet connection. So customers think, okay, what can I do with that? How can I connect disjoint networks so that remote device will be able to reach out controllers and establish both control plane connections and data plane connections? So that was the motivation for the customer. And this is totally valid reason. The question would be, okay, what I can do for that? And the customer think, okay, I know really good the IPsec or GRE from the previous days without SD-WAN. Maybe I can build a manual tunnel from my device to remote device which is connected to the MPLS network. And so basically interconnect those disjoint segments together to allow that device to obviously connect to both control plane and data plane. So technically, you can configure it. And the customer is really configured a tunnel, a manual tunnel, in a dedicated VRF, not a VPN 0, not a server-side VRF, but created a different one, and do some crazy magic with route leaking to make it work, to establish the tunnel. And even more interesting, that the control plane actually went up, and the IPsec tunnel went up. But BFD never went up. It never go up in that situation. And the question, okay, maybe they did something wrong, maybe they misconfigured something, but the point with that particular case is that they failed to really establish data plane. They can really do the pings from the tunnel interface on the remote location to all the controllers and the remote devices as well. So everything should be fine. But never IPsec tunnels along with BFD sessions were established. I can give you a second to think about it, why it happened. Okay, and let's explore that part. The reason is, it's not just connectivity we need to establish data plane. We establishing data plane only from interfaces which resides in VPN 0. There is a specific check in the software. Whenever we initiate IPsec tunnel and BFD session on top of it, we really need to be sourcing that session from an interface in VPN 0. Period. No way you can do it differently. And customer was playing with a dedicated VRF, which basically prevented that. And in the end of this, we will see what kind of debug messages you can double check to really confirm that behavior. So let's move on to that part. So first of all, you want to check the tunnel itself. In that particular case, we just have a manual tunnel, IPsec tunnel, what we configure for Flex VPN or just site-to-site VPN. Nothing fancy here. So we have VRF, we have IP address, and we have a default route which is pointing to the other side of the tunnel. Sounds good. But then once we understand that something went wrong, but we still not understanding why, we can run again. We do remember from the previous case that the process which is establishing IPsec tunnels and BFD sessions is the FTM process, forwarding table manager, running on average device. So we can run extensive debug for that process to really see what's going on and why it's not establishing a BFD session. And we can easily see that FTM process tells us, okay, no interface tunnel in default VPN, which is VPN 0. FTM tells us, okay, I cannot use that interface. It's not supposed to be used for establishing BFD sessions. So unless you know that limitation, unless you know how to see that process will report that, you might be trying to do very fancy assumptions how you can interconnect those disjoint domains. So from what you can do about that kind of cases. Unfortunately, in the end of the day, that setup and that design wasn't really supported and wasn't really validated with Cisco and BU specifically. So in that particular case, customer had to really redesign that part to reconnect it differently. But for the sake of science, I would say, you can technically try to move that tunnel interface from dedicated VRF to VPN 0, but still that would be not validated design. So I cannot really recommend you to do that. This is just to show you what kind of mistakes we can make whenever we're doing false assumption based on our previous experience. Okay, moving forward. The next one I really like. It's a little bit complicated, but I want to share that with you. And we see it quite often recently, I would say. And this is about traffic classification and application recognition specifically. So many customers are really leveraging concept of DIA, which is direct internet access. Whenever we have connection to the internet locally on a device, we tend to use that connection to forward traffic directly, let's say to Microsoft Office or Salesforce or any other cloud-based publicly available service. And to do so, customers are leveraging application recognition, which is built in every each device. We're using signature-based recognition, which tries its best to recognize the average application, average flow with the very first packet. And based on that, it steers the traffic from the overlay to the local breakout, which just totally makes sense because you're not really willing to forward the traffic into your data center and then move the traffic into the internet if you can do that locally. But with that approach, you can really find multiple ways to shoot you in your leg. And let me explain myself. So first of all, how you would do that. The policy is pretty simple. You just match in your application not based on the prefix, but based on the application name. But then, what customer is doing, what was the intent? You have a DIA, as I said. Then you selected specific types of applications, and you created the policy which is supposed to forward specific application into DIA local internet breakout, which is also DIA. And then what happens next? You're starting to see issues with both traffic destined to your internal networks and external services you are supposed to forward into DIA. You might be asking yourself, okay, why would I see that? And that's I going to cover in the next slide. But I'll give you 1 second just to kind of think about it. What could go wrong in that setup? Potentially. Okay. And you don't really need to read all this, the entire slide. I will explain it in a second. But I really need to explain something very crucial to application recognition. Whenever we're recognizing a flow and we are trying to match that flow to a specific application, we're doing our best to match that flow with the very first packet. And this is really crucial. Because it's not like you are able to recognize application and you are not able to recognize the application. It's not that simple choice, no. Sometimes you are unable to recognize it with the very first packet, but you can, when I say you, I mean device which runs N-bar application recognition. It can recognize application on a third packet or fifth packet, because it's starting to see the pattern associated with the application, and it's finally realized, okay, that's really that kind of application, service, Microsoft service, for instance. So not every each application could be recognized with the very first packet. That's the, I would say, the holy grail of application recognition, to recognize every each existing application with the very first packet. But unfortunately, this is not possible. So what we can do about this, and what kind of implication that behavior could really bring. So first of all, if we are not able to recognize with the very first packet, which is called first packet match, FPM, we have basically two options. We will wait up until the moment when that specific flow will be fully recognized or have final classification, so-called. And then we will forward the traffic in the direction it's supposed to be forwarded. Or we decide which way to forward that traffic, the entire flow, from the very first packet, which still not fully recognized. And both options are not optimal, unfortunately. Because very first packet might be misclassified, might be incorrectly classified. But the other way, if we switch over our flow to a different direction in the middle of the flow, we can break the entire flow. So we need to choose which option to use. Either we decide, okay, if we were able to identify that flow and specific application with the very first packet, we're good. We can forward the traffic perfectly fine. It will be absolutely compliant with our expectations. But if we fail to classify it with the very first packet, we have other two options. So we either use a default behavior, which is called flow stickiness. It means if we fail to recognize the application, we still be forwarding that flow into the same destination, no matter what, even if we change our classification to final sometimes later. This is just to kind of prevent disrupting the flow. Maybe we can forward the flow into DC instead of local breakout, and it will make it to the destination. That would be better option. So there's no silver bullet. And because of that, it's a kind of complicated choice. How we can deal with that? What we can do really to ensure that the traffic which is supposed to go to the internet will go to the internet 100% of the time? And the answer is we can't, because there's no technology out there which can guarantees 100% that every each packet will be fully recognized with every each time. But we can really use some techniques to increase that probability and chances to have that. So first of all, how we can confirm if we're hitting that limitation? So if we are really misforwarding traffic because we were unable to do a first packet match. Whenever you run a packet trace on a flow of interest, you can really see that the first packet was classified with MS services. But the classification is not final. It means application recognition still may change that classification after some time. On the other hand, we can see the final classification which happened to the same packet. That's the best case, when the initial classification and the final classification are the same. But in case you see the difference, that's the crucial part. The first packet classified application A, and the, let's say, third or fifth packet, or probably later packets for the same flow classified with application B. That's an indication of a problem. You really need to decide how you can classify that kind of traffic, because you might find yourself in trouble with that. So what you can do about it? The first recommendation would be to really implement a very simple policy, just to make sure that every traffic which is destined to your internal destinations, which is your internal corporate network, will be forwarded first no matter what. We don't really want to classify the traffic with application recognition, because we can really classify it based on the prefixes. That's the easiest one. It will solve at least one specific problem. It will ensure that all the corporate traffic, internal traffic, will get its correct destination no matter what. So incorrect application recognition will not affect internal corporate traffic. For the rest of the traffic, whenever you see such an issue, you really are might to think, okay, what optimization I can really use. And recommendation here is to use the more deterministic way of application classification. It's not always you need to use application recognition with N-bar. You can go with a prefix classification if you know that specific application you are trying to steer into the internet. You can really highlight or scope the destination prefixes with few lines. That would be option one. Another option to really use FQDNs, domain names. But whenever you use FQDNs, you really need to be aware that FQDNs are based on DNS requests we are running. And that's a caveat. Whenever you have a policy which uses FQDN for application recognition or anything else, for security policy, for instance, you really want to ensure that DNS requests coming from the client and DNS responses coming from the server to the client are going through the same device. So if edge device will not see those DNS requests both ways, it will fail matching that traffic. It's very important, and we see that quite often, because customers send in DNS requests one way through the one circuit, but receiving responses from a different one. And there's no symmetry in that. That's a crucial one. Then you if both prefixes and FQDNs are not feasible options for you, then you fall back to N-bar recognition. And finally, what you can do about asymmetric routing in that case, because asymmetric routing is I would say that's the most challenging part for application recognition. When one part of the flow, outgoing flow, goes into one direction in one tunnel, the incoming part of the flow coming from a different tunnel or a completely different device. In that case, the only option which could help to properly recognize the application is SDAVC. That's basically a solution which correlates all the data of application recognition from all the devices into vManage, correlates it into a single picture of the network from the application recognition perspective, and then uploads that information to all other devices. If you want to know more about application recognition, which is a very complex topic, to be honest, but it's very essential in nowadays, I highly recommend to visit a session of my colleague tomorrow morning. I think it will be at 9 a.m. It's called SDAVC Operations and Troubleshooting. And you will get the idea in a more sophisticated, more detailed way.
Question.
Yeah, sure.
Bullet number 2, if you're using FQDN-based matching, what if instead of that, we are just matching with the application name? And I've faced the problem even with the higher protocol pack version with the SDAVC, the classification is not correct actually. Because sometimes you're using the distributed application, so a part of it resides in, let's say, public cloud, and public cloud is redirected.
I'll repeat the question in a second.
Towards on-prem data center. And in that case, if you're matching certain traffic based on the destination application name, that recognition may not work seamless.
Okay, so it's rather a command or not a question, right? You're just going to make a statement. Okay, that recommendation, the command sounded like that. So we have a recommendation: try with the prefix first, then fall back to FQDN, then fall back to N-bar, then fall back to SDAVC. That's the way we recommend to consider building your application recognition. But the statement was, okay, it's not always works with the application recognition. And it's totally, that's basically what I'm saying. You can really have a 100% guarantee that every application will be recognized with an N-bar. You really, I would say you really need to to try it in your environment, to select your application of interest and see how those applications were recognized in your environment with a specific version of IO6E release. And based on that, based on those results, decide which way to go, how you want to build your policy. That's a recommendation I normally do. Okay, let's move on.
Good question.
Sure.
Shouldn't we prioritize SDAVC over NPAR? SDAVC deals with this.
The question is, should we really use SDAVC in from the very beginning instead of trying NBAR? And that's a good question because, again, there's no silver bullet, unfortunately. But with SDAVC, you will get more chances to address asymmetric flows. But also, you might find a different problem sometimes. Whenever you have a misclassification happened on a remote location, and you have two different views on each device sees the application, tries it with local NBAR application recognition, but it also has view from vManage provided by SDAVC. So whenever it fails to recognize the flow with the local NBAR, it tries SDAVC. And actually, SDAVC has a priority on the local NBAR. So we prioritize SDAVC. So and that SDAVC cache was not really kind of created from nowhere. There is another device which actually recognized that application. And if by any chance that application was recognized incorrectly, we kind of poisoned our cache centrally. And that poisoned cache will be deployed everywhere. So I would say SDAVC is not a kind of solution I would recommend for everyone from the scratch, unless you know that's the way to go. That's the only option you have to really recognize your asymmetric applications. Because sometimes there's nothing else you can use instead of SDAVC. Did I answer your question to some extent? I'm not sure. So let's take it offline. You can come back to me after the session. I will explain it a little bit in more detail. So I do recognize that's a very complex topic, but let's make it a little bit more simpler for the next case. So I call it creating a network black hole while we're trying to avoid it. That's an interesting one because, again, this is not an assumption based. This is mostly about how we follow the documentation without doing the fact checking or without double checking with the restrictions or limitations. We just see the very first recommendation and then not checking anything else. So let's say we have a SD-WAN network and we have two router design in a remote location, and we have layer 2 connected service side. Normally what we would do in that case, we just choose a first hop router protocol like VRP to ensure redundancy. So we will be able to forward traffic either way, which is totally makes sense and absolutely a common case. But the problem with VRP, it knows nothing about SD-WAN. It knows nothing about OMP. So whenever happens on OMP side, it's normally not recognized by VRP. So if we select it on a VRP side, specific path of forwarding, specific device to forward, we can really end up in black holing. And I'll explain it a little bit in a second. So what you would do, you just run a VRP, and then one of the recommendations we were posting some time ago to really configure that additional command, which is track OMP shutdown. What that command is doing is really tracking the state of OMP process on that device. And whenever OMP session goes down, we are considering that, okay, if OMP goes down, maybe there is an issue with data plane as well, because we are really sourcing from the same interface and the same port. We do an assumption here, but that's a valid assumption. And because we have two devices, we know for sure, okay, if we shut down, we see the OMP goes down, we translate or replicate that state into VRP as well. So VRP on that device will go down as well with that command. Okay? But sometimes we see that customers are not reading far enough in documentation. And there is a statement, you don't really need to place that command on both devices. You only need that, that command on one device. Okay, you have a question?
Well, are there any specific timers and how much time, seconds it will take to declare that it is down? And this track, is it part of IP SLA that you can also play around the timer? Or how to match these different timers to make sure it is down?
The question where those that track infrastructure is really built and where it resides. I guess I'm going to translate in your question, but it's not really related to SLA. So it's a embedded tracker infrastructure in IOSXE. You know that for ages, I guess. And we just, with that tracker, we're just checking the state of the OMP session. If it goes down, we instantly make that VRP session standby, not active. That's what we are doing. There's no timers we're using for that. Okay? Maybe I can explain it later in a little bit more detail. Nevertheless, so again, what really happens in that particular case? So everything worked just fine for quite some time. Whenever you have control plane up and running, both devices are forwarding traffic, VRP is operating fine. But then, all of a sudden, the entire data plane is isolated. And the reason for that was really because we configured that command on both devices instead first device, primary device. And what really happens when we configure it on both devices, which is totally not recommended. So whenever we lose control plane connections on OMP sessions, and that could really happen in multiple ways. So let's say we have a maintenance in with our controllers. So those controllers are going for upgrade, for instance. Normally, data plane should not be affected. Yes, we have OMP session went down, but we have a graceful restart for OMP. We can run for a few hours in a row with the same data plane, with the same routing table, etc. But in our case, because we see on both devices that OMP goes down for valid reasons, we decided to shut down VRP on both sides. And we essentially isolating our service side from the entire data plane. Data plane is still there, and it could forward the traffic, but we are not using that. With that just mistake we make by putting that command on two devices instead of one. So how can you confirm that? You can easily confirm it by checking few commands. So first of all, you would definitely go to each device and see if that specific command was configured or not. You can really show run command and look for track OMP shutdown on different interfaces. What you want to double check if it's not configured on your peer device in the same site. That's the most crucial part. So the key takeaway with that particular issue here. So you can really use that approach, and it really makes sense because VRP by default knows nothing about OMP and vice versa. So you can kind of connect those two different dots together, but you want to use it on one device only. And most importantly, we recommend it to use it on the primary device, not secondary device. And I have two more cases before we wrap up. And this one I called "You had to fight evil, not to join it," which is very reminding of certain movie. So what's this all about? You all know about the control plane tunnels we're establishing between the edge devices and the controllers, and we're using specific source ports for that. If it's DTLS tunnels, we're using ports 1, 2, 3, 4, 6, and there is a certain other ports we're using to switch over to them if we have failing to establish connections. So there are different ways how we can detect and try different options to really establish connections to our controllers. But this really could go very wrong whenever we are not aware of that and whenever we're using it incorrectly. So first of all, we have hub and spoke topology, which is totally makes sense. Then we not really want to use anything special. We know there is a lot of different safety belts, guardrails, which is built into our solution, which prevents us from doing something wrong or prevents the network to go down, like graceful restart, like decoupling data plane tunnels from control plane tunnels, SLA availability with the BFD. We have a lot of different means to keep lights on with that network. We also have different ways how we can detect whenever we are unable to establish control plane connection from a specific source port. So we can do so-called port hop to a different port and try again. It's also automatically done in the background if we fail to establish that connection for quite some time. So we're not doing anything fancy here. We're not trying to do anything fancy. So, and you run your network for quite some time pretty smoothly without any issues, but only for some time. Then you're starting to see that your data plane tunnels starting to flap from the hub device specifically. And why is that? Let's take a look. So first of all, whenever device loses its control connection and it's not able to reestablish that connection from the same port, from the same port for a period either from period of 3 to 5 minutes, it depends on the specific release, it will do that port hop procedure. Port hop procedure basically tells device to try a different source port to re-establish connection. We fail to do it with the existing connection, we try another one. But the problem with that, whenever we do a port hop, we are flapping our data plane as well. So it's totally okay if we do that on the spoke device, because spoke device is just one device which is responsible for one single site, and it has only a couple of tunnels. But if we run that, if we use that procedure of port hop on a hub device, we will see completely different behavior. We will flap all the tunnels across the network to all the remote spokes. So this is why we definitely recommend to avoid that configuration. The important part, port hop enabled by default on all devices. And whenever you run hub and spoke topology, first of all, you can really confirm if you're hitting that kind of limitation, but by going to the hub device, checking the configuration and see if port hop is disabled specifically. Because by default, there will be no command. There will be no command like port hop on a specific interface. You need to see no port hop on the hub device to make sure you will not fall into that problem. That's a recommendation. And then you keep your port hopping on the remote spokes, which is recommended as well. This is the way how you can prevent that. Disabling port hop on hub device, keep it on the remote devices. And a couple of other things I want to mention before we wrap up. With the IPsec rekey, this is very interesting one, because what we are really doing with establishing IPsec sessions, we can find ourselves with a situation when we do see some errors about IPsec. For instance, we see errors of which tells us, okay, there is some inconsistency with SPI. let's say we have out of sync key messages in our logs. So what we would do if we were running autonomous mode device, non-Cisco SD-WAN device in that case, we can try something like try and clear IPsec session, clear crypto SA peer. This is command from IKV2 period of our technology. But what happens next? You will definitely reset your IPsec session, but it will never come back. The reason why, because in SD-WAN solution, we really create IPsec session using iOS, like we did in the past days, but we are using keys not from IKV2, but from the OMP. We are receiving TLOC routes from OMP along with the encryption keys for the tunnel endpoints, and we're using those encryption keys provided from FTM to iOS, saying, okay, you really don't need IKV2 keys. You don't really need IKV2 to get the keys. Just use the keys we are providing. That's it. So whenever we clear the session with that command, we are clearing that session from iOS perspective. But we are not re-establishing or rekeying those keys from the SD-WAN perspective. So the entire network still thinks you have all the keys you need. So it's like a shooting in your leg by legacy command. And there's no way you can recover easily from that. Actually, you can, but you really need to know why you fall in that situation. So first of all, you can really confirm if you have that issue by seeing there's no packets coming into your IPsec session after that particular command. But then you can recover multiple ways. So first of all, you can manually do rekey in normal way, the way you should do in SD-WAN. You should use a different command. Instead of clear crypto peer session, you need to use request platform software SD-WAN security IPsec rekey. That's a quite long command. You don't really need to remember it. But recovery procedure is a different one. Clear SD-WAN OMP, or clear platform port hop, or clear control connections. After that, we will reinitiate the entire process of rekeying. So this is how you can really find you in a situation when you use a legacy command and it ruins your data plane. Please avoid using legacy commands. These commands are not applicable. We're trying to kind of eliminate that pitfalls with the new versions, preventing customers to really use those commands, but sometimes we really see that behavior. And the last but not least, so normally what would you, and this is my favorite, to be honest. Okay, so normally what would you expect from the SD-WAN network? You would expect that the control plane is decoupled from the data plane operations. Whatever happens in the control plane, that should not affect the data plane, and vice versa. But this is really not happens every each time. And sometimes it could be really tricky. So let's say we have a control plane tunnel goes down between vManage and vSmart. Do you think we can create a corner case when that outage could be translated into the data plane outage? Well, by asking that question, the obvious answer is yes, right? And yes, indeed. But the question is, how is it possible? Because the whole idea is really to have those two different planes decoupled. So there are corner cases out there. So I know I'm in the end of the session. Just give me 2 more minutes. I will cover that, and we will wrap up the session. So how is it possible? Let me explain that, really. So what do you have? You have SD-WAN network, and you have only private connection. So only MPLS connection. But the controllers are really residing in the Cisco cloud. So there is specific device in MPLS network which will make the translation, IP address translation for your private addresses. Okay, So whenever you reach out to the internet, most likely you will be, your connection will be translated for source address, which is called PAT, for an instance. That could be a firewall, that could be a PAT device, a router, whatever it is. And then, as I said, you could have that control plane flap in the background, which could happen in the cloud as well. But the problem with that, and let me explain it real quick because we are already running out of time with that particular diagram. What really happened and how can you prevent that? So we have that device which really reaching out to controllers through the firewall. And whenever it reaches to the vBond, it creates a new session. It creates a new session, a new translation with a new source port address. So let's say we have that control plane issue in the background between vManage and vSmart. What happens next? vSmart sees it loses connection to its vManage. What it does, and this is not commonly known, it actually tells everyone, including all other vSmarts and edge devices, okay, I've lost my vManage. So maybe you need to go to vBond and double check if vManage is still there, or maybe something changed for the vManage. It's just kind of notification to all other devices. But in our case, that message goes to edge device as well. So what edge device is doing? It's reestablishing connection to vBond. vBond sees a new connection from device it's seen before, but with a different port. It communicates it back to the device, and the device sees the port, the source port for myself changed, so I really need to do OMP TLOC update to flap all the data plane connection for myself. But because it happens for all devices, because vSmart connected to all devices, it really flaps all the data plane tunnels together. Just because vSmart tells us, okay, I have a different number of vManage connected. Please go to vBond. And whenever we go to vBond, vBond tells us, okay, something changed on your side as well. Please recreate your session. And normally that wouldn't be an issue if we either not having that firewall device or not having that behavior, not recreating the session just because vBond tells us that you have a source port changed. So how can you really prevent that? Again, this is totally expected behavior, but because customer was running a corner case when only single circuit with MPLS network connected to the cloud controllers, and there is a firewall which translates those IP addresses with a symmetric NAT. Only in that corner case, it really creates that an issue. So we actually recommending to deal with that. And again, there is some commands to really confirm if you're hitting that issue. I can skip it. So you can really find that vSmart tells you, okay, go to vBond again at a certain point of time. But then you can really, how can you prevent that in your case? So first of all, if you are not running that one single circuit with MPLS, you should be just fine. That's point number one. If you are running single private connection to the cloud controllers, this is where you would like to consider some other options. So option number one, which is not commonly feasible, is to use NAT instead of PAT. But that basically means you need to have multiple public IP addresses for every remote location, which is not always feasible for obvious reasons. The other option is really to use a new feature delivered in 17.14 version. That feature basically tells if you run a certain combination, that particular corner case, when you have MPLS or private connection, and whenever your source port is changed, and that change reported from the vBond, we are no longer recreating our session. We are refreshing our session. And because of that, we are not flapping the data plane tunnels. Even if you're facing the same corner case, running from 17.14 onwards, it will not be affecting you. It's a very interesting case because it really stretching the limits of the solution. When you really don't know if you're kind of standing on the bleeding edge of that guardian rail, which defends you across the SD-WAN solution all the time. But then, all of a sudden, you realize, okay, you're really about to fall. And you don't really know how you get there. How did you get there? This is why it happened. This is how you can prevent that. And as a final note, I would say my key to takeaway and the call for action for all these cases will be, don't make assumptions. Because these assumptions, all of these cases, most of these cases are really coming from the assumptions. The assumption, different assumptions. Assumptions, okay, whatever I do, control plane, data plane will be decoupled. Whatever I do, I can clear some connections in my case and they will be reestablished. Whenever I do, I will be fully safe. No, you can really use the safety belt and the guardrail the hard way. It could hurt you if you will use it incorrectly and improperly. So please, whenever you're using a corner case design or you have a very specific case which is not outlined in validated designs, please reach out to Cisco folks to really validate it before you're using that. With that said, I really encourage you to join me in the WebEx app. You can join the discussion. There is a dedicated WebEx space for that session, so you can ask your questions. I will take some questions right now. I apologize for delay above the time limit. But I think that was really valuable information for all of us. And I will really appreciate your feedback on that session and hope you will enjoy the rest of your week and the Cisco Live. Thank you very much for your time.